Hello, and welcome to Blue Team Toolbox. I'm your host, Edith Price. This week we'll cover Chapter 1 of Cracking Codes with Python. I'll leave links to Amazon and No Starch Press if you choose to purchase the books to follow along. This chapter covers the difference between ciphers and codes, the definitions of cryptography, encoding, decoding, encryption and decryption, and the Cipher cipher. Ugh, what a mess. There, that's better. Let's start with ciphers and codes. The code is made to be understandable and publicly available. One would need to substitute a message with a symbol. A fairly well-known example of this is Morse code, where a combination of dots and dashes make up letters and numbers of the English alphabet. Converting English into dots and dashes is encoding. Reverting back to English from dots and dashes is decoding. A cipher, on the other hand, is a type of code where the message is supposed to stay secret. A set of rules applied to a message can turn it into something that looks like gibberish. These rules often use a secret key to encrypt, change the message from plain text to a cipher, and decrypt, change the message from cipher to plain text. Cryptography is the science of using secret codes. Throughout history, anyone who needed to send a secret message relied on cryptography. Without it, spies and message couriers could be captured and their messages easily discovered by their captor. With the messages encrypted, the only way their captors could understand the message is if they knew the key to decrypt it. We shall begin our cryptography journey with the Cipher cipher, so named because Julius Caesar used it 2,000 years ago. The Cipher cipher works by substituting a letter with a different letter after shifting the alphabet over. For example, a shift of 3, starting from 0, would replace the letter A with the letter D, the letter B with the letter E, and so on. This can be done by hand using a cipher wheel. This wheel has 2 rings of letters. The outer ring will be the plain text, and the inner ring will be the cipher text. The inner ring also has numbers 0 to 25, representing the encryption key. The shift from A to the corresponding number on the inner ring. I've included a link to an online cipher wheel in the description notes if you'd like to follow along. So let's see this in action. We'll encrypt the message, leak the Deadpool 3 footage on December 1st with a key of 9. Reading the wheel from the outside to the inside for each letter, L becomes U, E becomes N, and so on for the entire message. After the encryption, our message becomes this. Now that we understand how this wheel works, how about you do one? This time, however, we'll decrypt the super secret very important message with a key of 4. To decrypt, you're going to read the wheel from the inside out for each letter. Pause the video and see if you can decrypt it. I'll wait. Go ahead and pause. Did you get it? This same type of cipher can be done with math. Oh, come on now, it won't be that bad, I promise. Really, it's simple plus and minus. We'll start with a small table with 2 rows. Top row will be letters, and the bottom row will be numbers 0 through 25. Now take the word cat and convert it to its corresponding numbers. C becomes 2, A equals 0, and T equals 19. Add 3 to encrypt. 2 plus 3 equals 5, 0 plus 3 equals 3, and 19 plus 3 equals 22. Flip back to letters and our word becomes FDW. To get back to cat, we flip our encrypted letters back to numbers and subtract 3. But what happens if our key results in a letter that's bigger than 25? No, don't panic. Simply subtract 26 from the total. For example, when we add the letter O, 14, with the key of 13, we get 27. 27 minus 26 equals 1, so O encrypts to B. To decrypt B back to O, take 1 and subtract 13, and we get minus 12. Now add back 26 and we get 14, the value for O. The Cipher cipher doesn't get stronger with double encryption. If you think on it a little, it makes sense why not. Encrypting the message with a key of 8, and then again with a key of 5 is the same as encrypting once with a key of 13. Next week, we'll cover Chapter 2, Programming in the Interactive Shell. This chapter covers some very basic programming concepts. See you then.